The first example to find the antiderivative, we're going to look at the integral of x cubed dx, which adding 1 to the exponent would make x to the fourth, and the new coefficient would be 1 over 4. So 1 over 4 x to the fourth plus c. Antideriving x to the fifth plus 3x squared dx, adding 1 to the 5. Antideriving x to the fifth dx plus 3 antideriving x squared dx, giving each term its own integral. X to the fifth would become 1/6 x to the sixth, plus then 3 x to the squared becomes 1/3 x to the third, and then plus the constant c. So that makes 1/6 x to the sixth plus x to the third plus c. Next integral is 4 square root of x dx. Rewriting first, we have 4x to the 1/2 dx. Taking out the coefficient of 4, that would be 4 integral of x to the 1/2 dx. Adding 1 to the 1/2, that'll make 3/2. So we have 1 over 3/2 as a coefficient, x to the 3/2, plus our constant of c. Reciprocaling the 3/2 to make 2/3. And multiplying 4 times the 2/3 to make 8/3, x to the 3/2 plus c. The next integral is the integral of 1 over 3x squared dx, separating the coefficient as 1/3 times 1 over x squared dx. Taking that coefficient out in front of the integral and rewriting as x to the -2. So antideriving, we have 1/3 1 over -1 x to the -1 plus c, which makes -1/3 x to the -1 plus c, or -1 over 3x plus c. The next example is the integral of x to the fourth plus 3x squared plus 1 all over x dx. Each term can get the own denominator of x, so we'll separate into separate denominators. Simplifying, we'll have the integral of x to the third plus 3x plus x to the -1 dx. Separating each integral as x to the third and the integral of 3x and the integral of 1 over x dx, which makes 1/4 x to the fourth plus 3 times 1/2 x squared plus the natural log of the absolute value of x plus the constant c. Then simplifying to get 1/4 x to the fourth plus 3/2 x squared plus the natural log of the absolute value of x plus c. The next integral is the integral of sine of x minus cosecant x cotangent x plus x squared. So give each term its own integral. So we'll separate integral of sine of x dx minus cosecant x cotangent x dx plus x squared dx. Antideriving sine x is negative cosine x. Antideriving cosecant cotangent is negative cosecant x. And antideriving x squared is 1/3 x cubed. Negative cosine x plus cosecant x plus 1/3 x cubed plus c. The next example, antideriving 4 cube root of x minus 5 square root of x cubed minus 1 over the square root of x. Giving each term its own integral symbol, we have 4 integral of the cube root of x dx minus 5 square root of x cubed dx minus the integral of 1 over square root of x dx. Rewriting the roots as x to the 1/3, x to the 3/2, and x to the -1/2, bringing that term from the denominator. Adding 1 to the exponent, so we'll have 1 over 4/3, x to the 4/3. Then minus antideriving, we'll have 1 over 5/2, x to the 5/2. And again, adding 1, we'll have 1 over 1/2, x to the 1/2, and then plus the constant. So reciprocaling that coefficient to have a 3/4. The next one to have a 2/5. And the last one is a coefficient of a 2. So the final answer is 3x to the 4/3 minus 2x to the 5/2 minus 2x to the 1/2 plus c. For the next integral, we're going to antiderive 8e to the x plus 2x to the third dx. Separating each term into its own integral, we have 8 antideriving e to the x dx plus 2 the integral of x to the third dx. E to the x is just e to the x. X to the 1/3 becomes 1/4 x to the fourth, and then plus the constant. So we have 8e to the x minus 1/2 x to the fourth plus the constant. The next example, we're anti-deriving 4 over x plus 5x squared minus sine of x plus 8 dx. Each term gets its own integral, so we have 4 over x dx, 5x squared dx, sine of x dx, and 8 dx. Taking out the 4 as a coefficient, anti-deriving x squared is 1/3 x cubed. Anti-deriving sine x is negative cosine x. And anti-deriving 8 is 8x, and then plus the constant. The integral of 1 over x is the natural log of the absolute value of x. Simplifying, we have 5/3 x to the third plus the cosine of x plus the 8x plus c. That's our answer. Anti-deriving the integral of 1 over x plus 1 over x squared minus 1 over x cubed dx. Each term gets its own integral, so we have 1 over x, rewriting the x squared, 1 over x squared as x to the negative 2, and the 1 over x cubed is x to the negative 3. Integral of 1 over x is the natural log of x. Integral of x to the negative 2 is 1 over negative 1 x to the negative 1. And x to the negative 3 becomes 1 over negative 2 x to the negative 2, and then plus the constant. Simplifying to write natural log of the absolute value of x minus 1 over x plus 1/2 with the x squared in the denominator as well. Anti-deriving x squared plus 3 times the quantity x plus 2. We can't anti-derive a product, so we need to distribute. So distributing our terms, we get x cubed plus 2x squared plus 3x plus 6 dx. Each term gets its own integral symbol. Then anti-deriving x cubed is 1/4 x to the fourth. X squared becomes 1/3 x to the third. X becomes 1/2 x to the second. And 6 is 6x plus the constant. Then we have 1/4 x to the fourth plus 2/3 x to the third plus 3/2 x squared plus 6x plus c.